And thank you for coming to this session. This is BRK3163, running your most demanding enterprise file workloads with Azure NetApp Files. So hopefully you're all in the right place, and if you're not, please don't leave. But anyway, as the name suggests, we're basically going to be doing a comprehensive walkthrough of Azure NetApp Files, including an overview of the service, and then also talking about use cases. My name is Andrew Chen. I'm the product management leader for Azure NetApp Files. So my team and I are responsible in partnership with NetApp for delivering this service. And I'm really privileged today to be joined by two co-presenters. I have Ramakant Pasunuri from British Petroleum, who's going to be speaking with us, and also Juan Pedro from Repsol, who will be sharing their Azure NetApp Files stories. So really excited to have them on stage with me later. So maybe as lead-in, I'll spend a few brief moments as to why did we build Azure NetApp Files and a little bit of background on this. So one, in terms of the general state of the space, hopefully this is pretty familiar to all of you, there's actually a significant amount of enterprise workloads that even to this day still remain on premises. Now, we talk to a lot of customers, and there's definitely a lot of interest, I think accelerating interest in moving to the cloud, but today a lot of it still remains on-prem. And a lot of it still remains on file-based storage. And actually, contrary to common reports, the demise of on-premise storage and file-based storage is still overstated because this is still a healthily growing space, right? There's a lot of businesses that would still be very happy with 24% annual growth. And so with that in mind, customers want to be able to move to the cloud or deploy workloads in the cloud, but compared to their existing on-premises solutions, they don't want to or can't or are unwilling to compromise on a couple key elements, right? And that includes performance. Sorry, there's a lag here. Reliability, availability, high availability, right? You're running your business on this. And then also integrated data protection and data management capabilities, right? And then of course, nobody wants to be forced to re-architect or refactor, right? How many people are like, oh yeah, that's something I just really want to do, or I have a lot of extra resources running around to undertake. So it was with that in mind that we built Azure NetApp Files, right? Our mission and our goal and what we're delivering is to enable customers to transition their enterprise workloads to the cloud without having to compromise and without being forced to refactor and re-architect. Of course, you can do so if you like. Now, as it turns out, Azure NetApp Files isn't actually just good for NAS-based workloads. We've had customers who have workloads on-premise that were either running on server or using direct attached disk, or even on SAN systems that they've also successfully deployed in Azure NetApp Files and seen really great results with. And then it also turns out that Azure NetApp Files isn't just for lift and shift, right? So we built it to enable lift and shift and seamless transition, but we've also had customers who have deployed sort of net new workloads or initiatives or partially modernized applications, for example, things that they sort of transitioned from a traditional on-premise architecture into containerized, and have used Azure NetApp Files to enable that in the cloud, and also seen really excellent success there as well. So sort of a variety of results. So how do we deliver this? A couple things is one, we start by offering the widest choice of file protocols in a single platform in the major hyperscale public cloud, right? We started the service with NFS v3. Since then, we've added SMB3. And then this week, we announced general availability of NFS version 4.1. And NFS 4.1, in particular, right now adds a valuable protocol-based file locking capability, which is very useful for certain deployments, including like a clustered database like SAP HANA Scale Out. Number two is we built and deeply engineered Azure NetApp Files to deliver on-premises or better class performance in the cloud, right? We want to be able to deliver the high performance to meet all of your requirements. But that being said, of course, not every workload requires the highest performance, so we also created multiple tiers. As you can see here, we have a standard, premium, and ultra tier so that you can choose the right combination of price, performance, capacity to meet your workload needs. And then third is we've delivered this through an Azure consistent experience, right? So you can access it through our portal. You'll see that later. You can access it through REST API. That also allows automated deployment. You can use Azure CLI, PowerShell, all of the normal means of access. Support. Support is provided by Microsoft. We wanted to make that a turnkey experience, and your normal Azure support entitlements also cover Azure NetApp Files. And billing is also integrated, right? Azure NetApp Files appears as just another line item on your Azure bill. Its consumption counts against your enterprise agreement commitments if you have it. It behaves entirely consistent from an Azure standpoint. And so what can you use Azure NetApp Files for? This list is by no means exhaustive, but some key workloads, and we already have customers who have deployed in all of these scenarios. General purpose enterprise file workloads, we'll talk a little bit more about that later. Database and database-based applications, including like SAP HANA, SQL. Containerized applications, serving as persistent storage underneath a containerized deployment. High performance computing and technical computing, where the performance of Azure NetApp Files, particularly combined with the cloud model, being able to scale up and scale down performance and burst VM capability and compute, has really provided tremendous value here. And then we're also seeing recently very high interest in using it for virtual desktop infrastructure deployments. And we're seeing this from customers across a range of verticals and industries. Again, this list is by no means comprehensive, but one area where we've seen great success is semiconductor electronic design automation for the reasons that I've mentioned. Also in the oil and gas space, which my two co-presenters are both from, and then also in retail and e-commerce. So last key thing, and if it's one of the few things that hopefully really sticks with you from the presentation, we've actually been asked by customers a fair bit about this over the course of the week. Azure NetApp Files is delivering the NetApp ONTAP technology as a fully managed service. So what does that mean? Number one, it is an Azure first-party service. We've partnered deeply and invested jointly together with NetApp to create this service. But at the same time, we wanted a seamless customer experience and singular accountability. And so to that end, it is sold and supported as a Microsoft product. Number two, Azure NetApp Files is just another Azure offering. If you happen to see the bare metal or dedicated workloads, I think Eric Lockhart really put it best that this is just another flavor and just another offering in Azure. It's not something different. It's not something off to the side. It's strategic and a long-term investment for both us and for NetApp, and we will continue to build and expand the platform and reveal more of its capabilities. So this is a product that you can buy with confidence. This is something that we've had inquiries about. And third, it is fully managed, right? We've invested a significant amount of the IP that goes into building in this service to automate and orchestrate so that you don't have to worry about administrative tasks like, oh, I have to upgrade the storage OS, or I have to do a firmware patch, or I have to worry about configuring high availability, or I have to worry about laying out the physical storage, where are my disks, RAID groups, volumes, aggregates. All of that goes away. All of that underpins the capabilities of Azure NetApp Files, but it's delivered as an easy-to-consume PaaS service. So spend a little time doing a brief walkthrough of the service itself. Some of the key concepts. One is from a capacity standpoint, we have a hierarchy. So if you start with an Azure subscription, the next construct under that is you create an Azure NetApp Files account, which is kind of an administrative concept. It's very similar, although different from our Azure storage accounts. And these are regional in nature. You have things like administrative rights or RBAC that you apply against the accounts. From a consumption standpoint, then the major important construct is a capacity pool. You can think of it as your gift card for purchasing capacity, and this is the basis upon which your consumption is billed. Capacity pool is then where you provision volumes to which you assign quota for delivering performance. So you can see the example here. If I have an account in US East, I've created a capacity pool. Capacity pool is at a given service tier. So you can see in the example here, I have one at premium, one at standard. Capacity pool is a minimum consumption of 4 terabytes. It can go all the way up to 500 terabytes in size. And then from that, I carve out volumes. Volumes can range anywhere from 100 gigabytes to 100 terabytes, basically within the confines of what I've allocated in the pool. So then the next key concept is the different tiers of the service that we offer, right? So we offer 3 service tiers, and the intent is to provide, again, different price performance thresholds so that you can meet your needs. And they sort of draw rough parallels to existing tiers on-premise, right? You can think of the standard as something that you might have seen from like a disk-based array or a very low-end hybrid array in the past. Premium is kind of your mainstream, SSD-based system, and Ultra is kind of your top-of-the-line flash-based system. They all have a different amount of throughput on a per terabyte basis that you allocate to volume quota, and I'll illustrate that in a moment, and different price points. Now, a key part of what we wanted to do with Azure NetApp Files from a pricing standpoint is to make it predictable. So we chose to price only on capacity and not inflict the dreaded transaction costs. And the intent is it's to be similar to what you do on premise, right? Is you have a given class of system with a given class of median, it gives you performance. You can exercise it as hard as it's capable of, and you basically pay for capacity only. So you pay here for the capacity, but there's no transaction charge, and you can basically exercise the storage all the way up to the limits of the tier. So how does performance work? So gone are the days of folks used to have to do any performance tuning. You'd have to think about like physical layout, how you striped your disks, all of that. That's all gone. There's no more complex tuning or optimization or calculation required. There's basically two key variables that you use when you determine your performance for Azure NetApp Files. The first one that we talked about is you choose your service level, right, which has a certain baseline throughput. So for example, here if I choose the premium tier, for every 1 terabyte of quota that I assign to a volume, I'll get 64 megabytes per second of throughput. If I multiply that by then the volume quota, so for example, I make a 2 terabyte volume, then the gross limit or throughput that I'm allocated is as much as 128 megabytes per second, right? It's the 64 by 2. And then you can use the doc link there. There's significantly more information in depth in terms of how you would size and do the performance. A couple key things to keep in mind is the QoS is set based on your volume quota, not based on the amount in the pool, and also not based on the actual amount of data in your volume. So for example, I can provision a certain amount of quota in the volume that's actually in excess of the amount of data that I have in the volume, and I can over-provision performance, and that sort of gives you another knob to tune how much performance you have versus how much capacity you require and your workload needs. So I'll go through a brief walkthrough of the portal experience here just to sort of show some of the concepts that we've talked about. So you can see here we're in the Azure portal. It looks pretty much the same as anything else. We have some Azure NetApp accounts already provisioned. It looks just like any other resource, and you can do the drop-down and choose from the regions that we have available. If you go into a given account, you can see all of the usual things. You do the overview, you have properties, you have the administrative rights. In the case of SMB, if you have SMB volumes configured, there's also the ability to add your Active Directory connection so that you can use that for authentication of your SMB volumes, and you'll get to see that later. But again, all very Azure consistent. So then you go into the account and you create a capacity pool, right? So you can name that. You choose the tier, and again, the tier determines the baseline performance that you're allowed. So in the case of this example, we'll go ahead and choose the premium tier, and you configure the pool, which in this case will just do the 4 terabytes. So that pool will have a total capacity of 4 terabytes and performance of 250 megabytes per second in gross. And then this is why I'm not doing this live, is you have this handy split screen, is you have the choice now. You can either create an SMB share or an NFS volume. When you do that, you name and sort of you assign the quota to your volume. You choose the private VNet into your network into which you will deploy this. In the case of SMB, you provide the AD connection information for authentication. In the case of NFS, you choose which version. There's an option to either choose version 3 or version 4.1, and the deployment is complete. So if anyone was keeping score or keeping time, in less than 2 minutes, you can go from absolutely nothing, just complete 0, to a full deployment of Azure NetApp Files. So I'm trying to basically cover, who, what, when, where, how. In terms of where is Azure NetApp Files regionally available, we are now available in 11 regions. Actually, the 11th one is very newly announced this week and is coming live. If you go in the portal, you may or may not see it, but give it a day or two and it'll come up. So we have the 10 regions worldwide, plus we just added UK West, and we're continuing to aggressively build out new regional footprint. And you can see there's the typical link for Azure here. Again, in consistency, you can go to the portal. You can look up Azure services by region, search for Azure NetApp Files, and you'll be able to see our regional availability and watch the space because we'll be continuing to grow. Now, We do still require whitelisting into the service. So if you've been following Azure NetApp Files for a while, it's been under whitelist control, and that is to sort of control and make sure that we keep our supply and demand in balance and that we provide a really great experience for customers. So we do require the whitelisting. However, also if you were there or if you requested whitelisting, particularly in the early days, of the service, we had a lot of pent-up demand. You may know that the queue times were really long then. We do still require whitelisting, but it's very rapid. So by all means, do feel free to submit the form, or I'll provide an alias later, and we can whitelist your subscription very rapidly and onboard you into the service. And again, we'd love to have everyone participate. So to sort of tie that all together, some sort of additional sort of tips, considerations, or things to keep in mind. One is you've seen ANF can deploy pretty much instantly, right? You can go from 0 to a full deployment in less than 2 minutes. And this can be done programmatically, so you can use an ARM template or other orchestration to have this be part of a deployment that you do. Another thing to mention is in the case you don't like Azure NetApp Files, you can also tear it down immediately, right? We do have a minimum capacity purchase increment, but we have no minimum time commitment. So if you go to the pricing page, it'll talk about how you have X pennies per gig per month, but you can basically tear down Azure NetApp Files at will. There's no time-based commitment. So the risk to try it, if you're thinking like, hey, is this something that can help on my deployment? By all means, feel free to, right? You can have it up, you can have it running, and if you don't like it, but I hope that's not the case, you can also be done with it practically instantly. So very easy to try. And again, what we also see is for high-performance computing or for burst workloads, customers take advantage of that. They'll deploy what they need. They'll ingest their data. They may spin up tens of thousands of compute cores, run their job, and then either dial back the performance capacity or evacuate the data. So something that you can take advantage of in terms of Azure NetApp Files being a truly cloud service and something that scales very elastically. Excuse me. Okay, related to that, another key thing that I think once customers find out and utilize, but if they don't, it's a pretty big aha moment, is that capacity and thereby the performance sizing is also dynamically adjustable. So if you have a volume of given size, and let's say I made a 10 terabyte volume and I have a certain amount of throughput, and I'm like, this volume is not going fast enough. You can over-provision it, and you can do it instantly. You can do this while the volume is mounted. You can do it while it's serving data, and you are actively exchanging I/O against it. You can do it with no interruption in the data path availability. And if you crank up the volume, so you're like, I need more throughput. I'm going to turn this 10 terabyte volume and increase the quota, make it a 40 terabyte volume. You can do that live. And the QoS changes that increase your throughput happen basically in near real time. So you can scale up your performance. And if it's, again, something where you have a deterministic need for performance, you can scale it up. And when you're done, you can scale it back down, right? So again, something that you can do in the cloud with Azure NetApp Files that was not possible on-prem before is you can borrow additional performance headroom at will, and you can return additional performance headroom at will. So something extremely useful. Another one is quota and pool behavior is worth explaining or clarifying a little bit. One of the key principles that we had when we designed Azure NetApp Files is that we wanted to protect against data corruption or data loss, right? We want to do that by not rejecting writes and not returning, say, like an out of file system error or something like that unless it was absolutely necessary. So one thing to understand is that the quota is a soft quota limit, and it's primarily for sort of budgeting your use of capacity and establishing the performance QoS. But if you do overrun the quota, we won't reject writes unless you are at the absolute limit of the volume, which is 100 terabytes. And again, the interest of that was to prevent data corruption. And if your volumes increase and your pool needs to expand, we will auto grow the pool as well to accommodate that. And again, you can always go back. You can then reallocate things and rebalance things as necessary. But we always wanted to basically take writes whenever possible. This behavior in terms of being able to elastically auto-scale up to 100 terabytes is also why if you run a df command against your volume, you'll see it say 100 terabytes versus say, like 500 gigabytes or whatever. So something to be aware of in terms of the behavior. And then the other thing, again, is your performance is allocated based on the volume quota. So if you have pool capacity that is not allocated to volumes, you might as well go ahead and do that and use all of your available pool capacity and allocate it to volumes that you have to maximize the amount of performance that you can achieve. The network topology is a really important consideration. So of course, an easy deployment is you basically just have a flat VNet. You have a subnet that you put ANF in, and all of your resources are in there. However, in many cases, in most customers, that's not the case. So we've seen a number of advanced topologies, including things like hub spoke, and then there's considerations there in terms of what central services you have in the hub versus what things go in the spoke. And then sometimes you have considerations like I have an express route gateway or a VPN gateway that has to go back to on-premise. So there's a lot of things that you start to have to consider. The link that is provided here provides a comprehensive guide of some of the sort of key factors, design considerations, system limitations around that. So we definitely encourage you to take a look at that when you're sort of planning your ANF deployment. And then sort of two key things to know or understand. One is Azure NetApp Files is highly secure. We've been asked by a lot of customers, it's like, okay, we need to go talk to your, we need you to talk to our security folks about, how ANF was built. ANF does not ever expose a public IP endpoint to present the storage. So if you're familiar with like our object storage or some of our other services where that storage is accessible over public IP, that is not the case with Azure NetApp Files. It's only ever present inside of your secure VNet. We were also not using VNet peering to present the service into your VNet. So it's not like there's another service VNet somewhere that has VMs or customers are like, oh, what ports do you have open or anything like that, and we're peering that into your VNet. We developed a new and proprietary network layer that securely takes the traffic from the underlying NetApp system in a secure and isolated fashion, injects that traffic only into your private VNet, and ensures that your traffic is always secure. And the systems physically exist within boundaries of the Azure data center, and they are operated to Azure security standards and are also protected by sort of the boundary we have in terms of security hardening, both operational and ongoing monitoring. And then at the feature level, we have a number of security features, including FIPS 140-2 data at rest encryption that sort of underlies the storage and basically all of the writes we do to media. And we also offer export policy, which is effectively the ability to set up firewall rules and either allow or deny based on IP address or IP range access to your volumes. And then a last key point is that Azure NetApp Files is HA by design, and that underlies the deployment. So one of the challenges in the past in terms of deploying, like if you had an NFS server, is if you have to deploy HA, it gets complex very quickly, right? You have to deploy a pair, you have to do clustering, you have to deploy load balancer, the administration overhead goes up, and then typically high availability, because you have to split your writes, comes at the expense of performance and scalability. And through the technology that we have, that is the problem that we've solved with ANF, is that we're able to deploy high availability, but also very performantly, and again, in a fully managed fashion. Okay, so what can you do with Azure NetApp Files? So first one is kind of the easy, like a migration or a lift and shift. So not too imaginatively, if you have an on-premise deployment, if you're running a private cloud or you have a virtualized environment, right, and you have your line of business applications or your users that are basically running in VMs, accessing data that's on some sort of on-premise NAS device or file server, you can basically move that over, right? You can have you can have your application VMs or your VMs move into Azure VMs, and you can move your data into Azure NetApp Files. And for some migration cases, although not all, NetApp does offer a managed copy tool called Cloud Sync, which is a heterogeneous ingest tool. It can bring in data from a number of sources, including SMB shares, NFS volumes, even object storage, and copy those into Azure NetApp Files. And for inbound migrations into Azure NetApp Files, there's no charge for this service. So you can use Cloud Sync or a third-party tool, depending on your requirements. You can migrate the data in, and you can set up a topology that's nearly identical in Azure to what you're running on-premise. Sort of on that topic, I'd like to transition over and bring up my first guest speaker, Ramakant from BP, who can share his story and journey with Azure NetApp Files. So Ramakant, thank you very much.
Thank you. Hi, everyone. Can you hear me? Yes, great. Thank you. So Andrew was talking about all the features that ANF brings in, right? Our story is more around the file share migration. As Andrew was saying, we are also one of the big organizations where NetApp filers have been in use for years. And as he was saying, nobody wants to discover all the data and transform everything, right? We want to lift and shift because there is so much of volume that is existing on-prem. And like most of you, we started our cloud journey, and we had a beautiful application migration strategy. We could strategize our applications to go to PaaS services, to go to IaaS services. We could even identify some of the workloads that can go into object store like Blob or Azure NetApp Files. But when it comes to NetApp filers, we have some challenges. Let me delve a little bit into the challenges when we were looking into how we want to transfer, right? I mean, I'll take different point of views on how the challenges were laid out when we started looking at the requirements. First, from a platform perspective, our service delivery manager is here. So, and Andrew was also talking about hub and spoke model. So probably BP is the first client to implement a hub and spoke model, where spokes are portfolio centric, and all the applications and their data reside in the subscriptions, which we call it as spokes. Hub is the one which is actually providing the networking component and all the controls around these spokes. So we want the spokes to be as autonomous as possible. That posed how do we give this self-service capability to the portfolio-centric spokes, right, without adding too much of management overhead? So when we started evaluating the products that are available, even before ANF was available, so we even evaluated Cloud Volumes on tap. Jeff is here, right? So Cloud Volumes on tap, when it was announced on Azure, it was not a high available solution. So without high availability, there is no way we can go into cloud and migrate all these volumes. Later on, Cloud Volumes on tap, it was made high available, but still the management overhead was never addressed. Again, it is more infrastructure as service deployment, so it's a decision. So then we started looking at from the migration team perspective, right? What are the concerns of a migration team? Migration team, the data center plan exit plan is already defined. So we have to transfer petabytes of data in a very short period of time. We have to look for some migration tool which can do that for us without impacting the primary line of application migrations, right? We need to ensure that their cutover is also going parallelly without taking any impact on it. From security standpoint, as Andrew was pointing out, we don't have enough visibility into these data sitting out there in these NetApp filers, so as to say that yes, everything can, this data can be transferred over internet or to other stores where the public endpoints are there. So it is a big no for transferring anything over internet. So it has to stay private. Last but not the least, users, right? That's where the performance comes. So what were users concerned about? Users were very skeptical. All these file shares were sitting next to me in this building. Everything was performant. If you move it to cloud, will it be performant enough, right? So those are the concerns that we started off when we started looking into ANF, combined with the delegated subnets that Andrew was mentioning, where probably we are the unique customers with the transitive routing. So with delegated subnets, we could completely keep the traffic on private networks. We could address security concerns. We could get the throughput that users were looking for. To our surprise, again, this is user feedback, but cross-continent, the performance was better in Azure than what we have seen on-prem. So that performant the solution was. And coming to migration teams' concerns, how we have addressed, we have looked at a couple of tools that were available. And CloudSync could have helped, I guess, but again, these filers have been sitting there for years, and our security concerns, our security implementations are not something which were helping. So we looked at various tools, and StorageX is one tool that we partnered with, which gave us the throughput of 35 terabytes per day, and without impacting any of the application migrations. So with that, what we could do is we could move petabytes of data in a period of 4 months. So that's the volume that we are looking at. And how did we address the platform concern? I mean, as Andrew was pointing out, it takes minutes to provision these capacity pools and capacity, all the volumes, right? So we could make it completely Azure native experience. We could drive ARM templates. We could make self-service automation capabilities. And there is no management overhead. So teams are completely self-servicing. So we just go, once the service is enabled, the spokes or the portfolio-centric teams are on their own. They create their volumes, and then they can start migrating. So with that said, one last thing that I would like to mention, the key success factor in this whole journey was the partnership, if I can say, right? Microsoft NetApp has always been there, and the regions that you have seen earlier, some of the regions were actually prioritized based on BP needs, and thanks to Microsoft and thanks to NetApp. Actually, I mean, they worked with us. We wanted in South Central, they gave us in South Central, and then we wanted in North Europe, and they gave us in North Europe. So that's how the partnership really helped us. And also the resolutions, right? I mean, issues that as soon as we said, I mean, we are unique and we are doing transitive routing, Andrew was there to give us a fix. So that partnership also really helped us. Thank you very much, Andrew, for everything. I mean, I hope the use case resonates with all you, and if you have any questions, please do let me know. Thank you.
Ramakant, thank you so much. And thank you for the partnership. So yeah, thank you to Ramakant and to the BP team. So another use case progressing along is database, right? So SAP on Azure. Hopefully some of you were able to take in the talk yesterday. There was a deep dive in SAP on Azure, so I won't go through all of that. If not, I'll provide the link so that you can pull up the recording once it's available. There are multiple ways that Azure NetApp Files can help with SAP deployments. The first one is a simple but sort of insidious deployment consideration with, most SAP landscapes have a dependency on this thing called the shared files, right? So it's the SAP mount, transitive files. There's this small piece of NFS storage that an SAP landscape requires that was actually really thorny to deploy in the cloud up until recently, right? Most customers had to stand up some sort of cluster or NFS file server just to present an NFS v3 volume that this deployment required. And so from the very, very early days of Azure NetApp Files, we actually had a lot of customers who were using ANF to provide this. So it was compatibility, right? We had NFS v3, the version that everybody wanted. It was easy to deploy as a PaaS service. It was reliable, and it rapidly met this requirement. Then the more interesting thing, though, is, of course, the database, right? So for those who are familiar with SAP HANA, being an in-memory database, it's extremely performance intensive, and so there's a very specific set of performance KPIs that have to be met before HANA will support your deployment as certified and listed in their hardware catalog. And those performance benchmarks are particularly stringent on latency and throughput, which is really hard to achieve in that combination in public cloud up until now. So we've been very pleased to announce at Ignite that Azure NetApp Files has passed and is formally certified for SAP HANA databases and logs, right? And we are the only managed file share solution in the hyperscale public cloud that has achieved this and that is technologically capable of achieving this. And then related to that, because it's built on the NFS version 4.1 protocol, which has the protocol locking that I mentioned previously, we in Azure are also uniquely able to support SAP HANA scale-out N+M with standby node deployments, right? So otherwise, you have to do an N+N clustering. What N+M allows you to do is achieve the greater performance scale and reliability, but at a much more effective, with a much more efficient deployment and cost point. And again, Azure in combination with Azure NetApp Files is the only hyperscale cloud that is able to deliver this value to customers. So since we're now on the topic of performance, I'd like to invite up and turn over to my next guest speaker, Juan Pedro from Repsol, who will share his journey with and his story with Azure NetApp Files. So
Thank you, Andrew.
Thank you very much.
You. Okay. Hello, everyone. First of all, let me explain a little bit about Repsol. Repsol is an energy company in more than 35 countries, based on Madrid in Spain. Our headquarters is in Spain. But the exercise, this particular exercise, is based on the oil and gas industry. the need we have is that we have reservoir engineers. The reservoir engineers, what they do is they do simulation of the reservoir itself, so fluid dynamics on the cell, on the subsurface. This simulation actually is based on building blocks, creating a grid, or with the blocks, and in between those blocks, adding the properties of those rocks and fluid. So we study how the fluid is behaving or moving under the ground. So the problem that we have is that we have a problem that it has a lot of CPU intensive, a lot of storage intensive, and as well also GPU intensive, because we are creating big and huge, actually, three-dimensional models of that environment. So the idea what we have is we thought, hey, how about if we can provide the same infrastructure that we have for maybe a few engineers in the company for being able to simulate those models. As you can imagine, we are talking about hundreds of cores that we need in order to simulate one of those models. So the problem is that companies usually have like a few data centers around the globe, but maybe that's limiting the capacity of our engineers. So we thought maybe we can expand that capacity to more engineers around the globe. So we thought about Azure being a solution for that. So the exercise is moving from a few hundreds of cores to 1,000, more than 1,000 cores. And actually, one of the other benefits that we are seeing is that we are able to provide on-demand capacity. As Andrews mentioned, this is on-demand on creation and instruction of the whole environment. So we can create maybe an HPC cluster that maybe has, I don't know, 400 cores in a matter of hours. So in a matter of a few hours, we have 400 cores created. So we are able to use using the software for simulation. In some way, the exercise, the whole in production product that we have is lift and shift in a third-party application. This application that we are using for the simulation is not ours. It's just we are licensing the application. So we are moving a Windows application to Azure, where actually it runs on those virtual machines. Those virtual machines are connected to this storage. And also, on top of that, we are able to study or use that information that we are generating by the simulation inside the same Azure architecture. So what I'm saying is, as I showed in the graph, we are creating those HC, high computing capacity machines, the simulations, and then using the NV, the family that has NVIDIA graphic cards, being able to analyze the study. So what we are providing to the user is a virtual desktop environment that actually gives the engineer and the geoscientist a new capability that they are able to work from anywhere around the globe. As you can imagine, there are some locations that the latency will not allow you to that, but the thing is that instead of being the users as is today, we're able to just work from our head offices, to be honest, mostly in Madrid and in Houston, Texas. Now they're able to work even if they are in a data room or outside for doing or whatever, even in a conference. So, one of the key factors that we saw, even though that technology allowed us this part, we also saw that there was an improvement in performance. I remember one example that we created a completely new environment for an engineer for doing some simulations. Actually, it was an uncertainty analysis. Maybe those analysis requires, I don't know, thousands of simulations. And maybe each of the simulations takes like a few hours or to run. So he thought that he has no better idea that tries his first exercise to replicate an uncertainty analysis that he had done in the past. That he told me that exercise took him like a month to run. So what he did is in the afternoon, he said, okay, he set up the environment, and he clicked on the run, and he left home, and the next morning he arrived back from home, and he checked on the queue on the application, and he saw that there was nothing. It was finished. It was closed. So he told me that, you know what, I was about to call you because I'm saying, hey, this is not working. This is like, this crashed, the whole thing crashed, and I have no results. But before, when he was calling me, he was checking on the queue, and he realized that actually the whole exercise was done. So actually, of course, now he had more cores because of this scalability and this elasticity that we have today with this environment, but he was solving a problem that usually took like a month in overnight. So that kind of ideas, and also the idea of now I'm able to have an environment in a few hours. As I said, we are able to create a whole environment, a whole simulation environment in a few hours. Consider that before it took us months. Consider that we will have to contact procurement, decide the architecture, go into all the legal and technical parts of contacting HP, Dell, whoever, and saying, hey, you know what, I need to set up a new environment here, there, logistic. Now, you can have it in a few hours. So let me see. So again, we're no more than good things about this environment. And as my colleagues mentioned, the great thing about this was that we understand, we as a reps understand that this was a great idea. We found a way to make it happen, actually, and with the help of Microsoft and the people from NetApp, we were able to make it run in no time. Because in some way, let's not forget that we were replicating an architecture that you used to have locally on-premise. We were replicating that architecture in only a few months of work in Azure. Okay. So thank you very much, everyone. And I hope this exercise opened you some ideas, and maybe you were able to try it and see from yourself the performance increase. Thank you.
Thank you so much. Thank you. Yeah, so thank you to both of my co-presenters. All right, so wrapping up. If you've been following Azure NetApp Files, we've been busy since the last Ignite. We had originally only one tier. We added 2 new tiers, Standard and Ultra, which I talked about. We added SMB3. We made enhancements in the network. So again, we did not have VNet peering before, which we implemented. And so we were able to support a greater number of topologies, as well as routing through the VPN and ExpressRoute gateways. And we've been very busy building the service, right? We added 8 new regions worldwide, actually now 9. And then we went from preview to general availability. And here at Ignite, we're formally announcing the GA of the NFS 4.1 protocol, as well as the certification for SAP HANA. So some things that are coming soon. 2 key capabilities. Of course, this is not the end of it all, but things that are somewhat near term is 1, the ability to restore a snapshot in place, right? So today you can restore snapshots. You can send those to a new volume. We'll have the ability to actually rewind a volume in place to a prior point in time based on your snapshots. And then the other one, this is probably one of the top most requested features that we have, is cross-region replication, and the ability to set up a replication relationship between 2 ANF volumes. And then we are continuing to invest and aggressively build out the regional footprint. So there's a few there that are coming in the next few months, but we intend to expand that list greatly over the next year and years to come. And then I want to leave everyone with some resources. So a number of links in terms of how to request onboarding. Both our marketing pages and our documentation pages are really well done. They have a wealth of knowledge, including some deep articles on some of the concepts that I explained here. We also have a solution architecture page that covers the use cases I mentioned here, as well as a number more, and it's constantly expanding. So if you go to that aka.ms/ANF solutions, you can look there for some, either some more documentations on what you heard or some inspiration on patterns. If you liked the demo, I have to give credit. There was one of our partner technical folks at NetApp did that really excellent demo, and actually has a playlist illustrating some of the other concepts, including snapshots and some of the other capabilities. So that QR code will take you to that site. And then lastly, as a catch-all, we have the alias below. So please feel free to use that with questions, comments, feedback, or you're like, hey, where's my whitelisting? So by all means, please feel free to use that alias as well. Unfortunately, without the benefit of a time machine, one of the disadvantages of going later in the seminar is some of these sessions are past, but there are a number more broadly within sort of Azure Storage, Media, and Edge, a number of other sessions that cover a variety of storage-related topics across Azure. So if you have interest in those, you can look at the codes and then play the recordings once they're available. And then last but not least, please do fill out the evaluations and provide your feedback. But hopefully this session and the content was valuable for you, and thank you very much for your time. Really appreciate it, everyone.